I want you to notice something. At no time does it tell me what angle A is. It just says find what sine, tangent, and cosine are for that. This is 20, this is 10. So, Ms. Ramirez, I want to find, what's the first one? Sine? Sine of angle A. All right. First thing I need is figure out which side of triangles I'm talking about. Which side of triangles am I talking about? Opposite. So that's opposite. That's adjacent. Oh, that's not. I should have said that. That's the opposite, right? Yeah. You okay with that? Hypotenuse and adjacent. Okay? So sine is opposite over hypotenuse, but I don't know what the opposite is. So I'm going to have to solve for it. How do I solve for it? Pythagoras?
Oh, yeah.
All right, remember our friend Pythagoras. So we're going to go, you need to take a break here. 10 squared plus the opposite squared equals the hypotenuse squared. 10 squared is? Opposite squared, 400, right? Bring the 100 over. Oh, sorry, what'd you say? Okay, and now what? Square root opposite equals plus or minus the square root of 300. Oh, minus is silly. We're not going to do that today. Square root of 300. Can I simplify that?
Yeah.
How do I do that?
So then you do the like 300.
So give me two numbers that multiply and give me 300. 103. Square root of 3 times the square root of 100. Well, let's just keep going. What's 100? Give me two things that multiply and give me 100. 2 and 50. It's a little rough, but we'll do it. So that's root 3, root 2, 50. 25 and 2.
And then would do 5 and 5.
Root 5 and root 5. Okay, can I do any more?
No.
Okay, any pairs?
Yes, the 5.
Pair of 5s?
And 2.
Pair of 2s? Here's my root 3. So this side over here is 10 root 3. Agreed? Okay. Now we're back to where we started. What's sine going to be?
10
Root 3.
And then 20.
Over 20. I could simplify this because I know how I can take a 10 out of top and bottom. So this is going to be root 3 over 2. So that's how you find sine. What about cosine? Yep.
So 10 over 20.
Cosine, so it would be adjacent over hypotenuse. So that'd be 10 over 20, which is?
So 2. Wait.
No way.
Divide top and bottom by 10.
5.
Right? Flipped it. Then tangent of A.
So 10 square root 3. And then 10. So 3, yeah.
And that's what those are. All right. Now, Ms. Huber asked me an interesting question before, and I may have misunderstood her. So let me give her one other thing. So I'm not going to let you have the table when you go to take the test. I need to know that cosine is adjacent over hypotenuse. Are these things you memorized, or should I give you a better way to remember them? Okay, good. I think most people can use that, so I'm glad you said that and volunteered for it. So we used to have a geometry teacher here that used to talk about some weird tribes. She called it the Sokotoa tribe. And she used to spend 45 minutes of class time describing this tribe and how they did weird things with triangles. I try not to think too hard. She was a nice lady. She called herself Princess Geometry, and that's what she actually has wanted to be called in class. So we'll leave it there. But the Sokotoa thing is legit. What? It's not a tribe. And it's So Ka Toa. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. You gotta make sure you have that H and that so. Other than that, you're good to go. Is that okay? Just say SOHCAHTOA about 12 more times and it'll be stuck in your head and you won't have to worry about it. Yeah. I mean, 45 minutes of class time. Kid you not. She tell them about this tribe and how they discovered weird things about mathematics. It's like, what are you doing? Anyway, I saw her the other day. She was wearing hippie attire and was hanging out in a tent on the side of the road. All right, moving on. And she's older than I am by a lot. Anyway, good so far? Okay, so flip this over. Let's do the top part of 3, 4. Let's do problems 1 and 2. Go. I just recorded that. That's probably not good. I didn't name names. Nobody's going to know who it really was.
Who was it?
I'm not, no.
The chem teacher.
Definitely not doing it.
So the root of 3. So that's 32. So 10 root 3.2. That was smart. 8 root 5. So that's height.
What? Oh, shoot. Start over again. Sine B equals, let's B down here, right? Okay, B, let's do it. Thank you, by the way. I could be doing this for long. So sine of B is going to be 3 over 8, right? So cosine of B would be root 55 over 8. And then tangent of B would be equal to 3 over root 55, which is problematic because I got a root 55 on the bottom. How do I solve that problem? Root 55, and I get 3 root 55 over 55, and I am done. Thank you for catching that. Whoever said that, thank you. Going to do number 2. Then we'll talk about the 3 more, because 3 trig identities is not enough. We want to have 6. Yes, ma'am.
Do you know which one goes where?
Okay, so in the case of B, B's up here, correct? So what I should have done is I should have said, well, this is my opposite.
Yeah, no, how do you know which one goes where in the actual equation? Like, how do you know it's not 8 squared?
Oh, this is always the c squared on the right-hand side.
Okay.
Always. It's got to be the log side.
So then,
So I chose 8 squared for that, and then the other 2 or whatever's left over. You good? Yeah. And cosecant, I'll put angle A, secant, and cotangent. Now, cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite.
It's the same thing.
They're the same thing as they're flipped. So sine of A is equal to 1 over cosecant of A. Cosine of A is equal to 1 over what? Secant of A. And tangent of A is equal to 1 over, tangent of A is equal to 1 over cotangent of A. Yeah, secants actually work.
For your abbreviation, is it CSC?
See it? That's cosecant.
Yes.
Yes, CSC, yes. Now, this is a holdover from back in the good old days when we couldn't actually put a fraction in a textbook. These are dying, but they're not dead yet. They appear often on things like AP calculus tests and on things like SAT tests. So we have to know what they are. But sine, cosine, and tangent would do the job without these other weird things. So how are we going to remember them? Here's the way I tell my students to remember them. Cos go with non-cos. What? Tangent doesn't have a co in it, so tangent goes with cotangent. They're just flips of each other. Secant doesn't have a co in it, so it goes with cosine, which does. So it's 1 over cosine. And cosecant has a co in it, so it goes with sine, because it doesn't have a co in it. Okay, so cos go with non-cos, it's just a flip. So cosecant is with sine, secant is with cosine, and cotangent's obviously with tangent. And they're just flipped. Okay? That's about all you need to know about cosecant, secant, and cotangent. We're not going to spend much time on them, except that you have to know them somewhat. With that in mind, everybody try the weird problem that is the number 3 problem on the front, I believe. Which has surprisingly lack of works, but it is actually doable. Okay, for number 3, tangent of theta equals 5. What's cotangent equal to?
1 over 5.
All right, this is 5 over 1, so cotangent would have to be the inverse, which would be 1 over 5. All right, this is officially the first time I've introduced this variable, so I should probably mention that little gem. This is the letter we're going to use for almost all our angles going forward. It's a theta. It looks like this. Theta. Okay? So if you run into that, that's what it means, theta. Now, it's just a variable like x, y, z, t. You guys okay back there?
Yeah.
This is a variable like a, b, c, d, e, f, g. It's just when we get to angles and more advanced classes, we start using thetas to represent that's an angle rather than something else. Is that okay? All right. If we try the second one, number 4, it should be easy if you're getting the drift. If you're not, I need to help you out because something's wrong.